Okay, let's get right into it. For a while now, it's felt like there was this growing gap in the AI world. You had the open source models, which are incredible, but they just seem to be falling further and further behind the closed source giants. And then DeepSeek V3.2 showed up. And believe me, it didn't just join the conversation, it completely changed it. So here's the fundamental problem everyone was seeing. That performance gap between the big proprietary models and their open source cousins, it wasn't closing. In fact, it was getting wider. The big closed models were just accelerating away, leaving the open community trying to play catch up, especially when it came to the really complex stuff. But, why was this actually happening? Well, if you dig into the research, it really boils down to three very specific, very critical hurdles that were holding these open models back. Let's break down what they were. Okay, first up, a major architectural problem, long text inefficiency. Basically, most open models were really bad at processing long documents without getting bogged down. Second, it was a resource problem, less training power. They just weren't getting enough computational firepower after their initial training to really sharpen their skills. And third, there was a big skills gap, weaker agent skills. They were seriously lagging in their ability to use tools and actually interact with the digital world. And this is exactly where DeepSeek V3.2 steps onto the stage. See, this wasn't just another small update. It was a targeted, deliberate engineering effort designed from the ground up to solve these three core problems. So to fix that long text problem, they came up with something called DeepSeek Sparse Attention, or DSA. The whole idea here is a brand new way for the AI to pay attention that is just radically more efficient for huge chunks of text. And this is the key, without losing any performance. And this is the perfect way to think about it. Instead of just trying to brute force its way through every single word, DSA lets the model intelligently scan and zoom in on only the most important parts, kind of like a researcher's scanning a page for keywords. This saves a massive, massive amount of computing power. Next up, to fix that training power issue, they built a new protocol for reinforcement learning, which is really just a fancy way of saying you train an AI with rewards and penalties to get it better at hard stuff. But the critical part here is the scale. They threw a post-training compute budget at it that was more than 10% of the entire pre-training cost. I mean, that's a huge, huge investment, all designed to sharpen the model into a razor's edge. And yeah, that's the perfect analogy, right? This isn't just a quick cram session before a test. It's a full-on, high-intensity training camp. It's the Rocky montage that takes the model from just being smart to being a true world-class performer. And for that third problem, the weak agent skills, well, they built a custom-made training ground. It's this automated pipeline that generated this ridiculously huge and diverse set of challenges. We're talking over 1,800 different digital environments and 85,000 unique problems, all designed specifically to teach the AI how to think, reason, and use tools like a pro. And this diagram here shows another really clever part of that agent training. The model actually learns to be way more efficient by remembering its thinking process. So instead of starting from zero every time it uses a tool, it keeps its reasoning and memory. This stops it from redoing a bunch of work and just makes it a whole lot smarter and faster. So, okay, they built this challenger from the ground up, targeting the exact weaknesses that held back other open models. But the real question, the billion-dollar question, was, did it actually work? How did DeepSeek V3.2 actually do when you put it in the ring, head-to-head with the best closed-source models on the planet? Well, the results were, honestly, they were stunning. Just look at this table. In complex math, it's right up there with the top dogs. In coding, it's totally competitive. But check out the agent score, the tool use score. It's actually beating GPT-5-high and is right on the heels of Gemini 3.0 Pro. This is a massive, massive leap forward. So the bottom line, the really critical takeaway is this. For the first time, an open source model had finally reached performance that was on par with a top-tier proprietary model like GPT-5. And it did it on their turf, the all-important domain of reasoning. And this matters so much because it means developers everywhere, not just a handful of huge companies, can now get their hands on this kind of power. But wait, it doesn't even stop there. Achieving parity wasn't quite enough for them. The researchers asked this other amazing question. What could this thing do if we just took the training wheels off completely? What if we just let it think without any constraints? And the result was this experimental version they called Speciale. And I'm quoting the paper here. It achieved performance parity with the leading closed source system. Not just competitive, parity, and equal. And it didn't just do well on some benchmarks. It showed gold medal performance in the world's absolute toughest academic competitions. And this is where things just get unbelievable. The real-world impact is insane. We're talking gold medal level performance at the International Mathematical Olympiad and the International Olympiad in Informatics. I mean, this is the absolute pinnacle of high school math and computer science on the planet. Seriously, just let that sink in for a second. A score of 35 out of 42 on the IMO. For decades, this has been one of the grand challenges for AI, and now an open-source model has reached a level that would earn a human competitor a gold medal. It's just wild. And it didn't stop there. It placed second in the ICPC World Finals, which is one of the most prestigious university-level programming competitions in the world. This is just completely unheard of for an open model. So look, this breakthrough doesn't just close the gap, it blasts open an entirely new frontier for open-source AI. But the researchers are also really upfront about the work that's still left to do. They're quick to point out that it still has some ground to make up in its general world of knowledge. Its token efficiency could be better, meaning it can sometimes be a little chatty to get to the right answer. And of course, the most complex tasks out there are still a huge challenge. These are the next mountains they have to climb. But this fundamentally changes the entire landscape. For the first time, truly frontier-level AI reasoning power is accessible to everyone. And it just leaves us with this one profound question. Now that this kind of power is in the hands of the global community, what incredible things are we all going to build next?